Hello friends, after a long time I am back again with one more set of video for class 12 mathematics. Mm, that is topic based on derivative, and it is also a very important topic for CBSE as well as ISC. The topic is Rolle's theorem and Lagrange's mean value theorem. So I suppose all of you are fine and you all are understanding what I am trying to explain. If not, surely you comment in the comment box. Any type of suggestions are always welcome, and I hope this video will be also very useful for you. So I was talking about Rolle's theorem. ये जो रोल्स थ्योरम है ये डेरिवेटिव से रिलेटेड है. सो इट कैन बी ऑल्सो टेकन एज देन एप्लीकेशन, और डेरिवेटिव का कोई एप्लीकेशन इसको मान के चल सकते हैं. तो इसका थ्योरम का स्टेटमेंट इज सिर्फ इम्पॉर्टेंट है. इसका प्रूफ वी आर नॉट गोइंग फॉर द प्रूफ ऑफ द स्टेटमेंट, rather only the statement and its application, and obviously the geometrical interpretation of Rolle's theorem has also to be understood. So what does the statement say? Suppose we have a function y is equal to fx, and the function satisfies three conditions. What are they? First condition is fx is continuous in closed interval AB. Fx is continuous in the closed interval AB. Next, fx is derivable in the open interval AB. I suppose you all remember what is the meaning of closed interval and open interval. If not, let me recall. Closed interval means the point A and B both are included in the interval, and open interval means excluding the points A and B, all other points within the interval are taken for consideration. And third one, the function satisfies is f of A equal to f of b. That means the functional value at the endpoints if they are equal. Three conditions we have. First one, fx is continuous in the closed interval AB, fx is derivable in the open interval AB, and f of A equal to f of b. If these three conditions are satisfied, then what we can conclude? We can conclude that there exists C in the open interval AB such that f dash C equal to 0. That means we will get a point, obviously we will get a point in between the interval A and B. At least one point. We will get at least one point in between the interval AB such that f dash C is equal to 0. Now, this is what the statement of Rolle's theorem says. Now, what type of question usually comes in ISC? That is, you will be given a function and you will be asked to verify whether the Rolle's theorem is applicable for that function, and what is the value of C for which the function vanishes or for which the function becomes 0. So this is the statement. Now let us understand what is the geometrical interpretation of this theorem. Geometrical interpretation. Now let us come one by one with the statement. First is fx is continuous in the interval AB. Continuous means the graph or the curve of the function fx will be continuous. That means we will get a continuous curve in between the interval A and B. Second one, fx is derivable in the interval AB. That means the derivative is finite in the interval AB, open interval AB. Finite. If the derivative exists, then at every point within the interval A and B, the tangent also exists. Tangent, we know it is dy by, the slope of the tangent is dy by dx. That means if the derivative exists, then only slope will exist, and if the slope exists, the tangent will exist at the 2 points, in between the two, all the points A and B. Third point, that is fa equal to fb. Now if x is equal to a is here and x is equal to b is here, then this obviously becomes fa and this becomes f of b. So these two parts are equal. That means the ordinates are equal. fa equal to fb means the ordinates are equal. So if these three conditions hold, then f dash c is equal to 0. F dash c equal to 0 means at a point in between A and B, we will get somewhere C, let us take here, where the tangent is 0. The slope of the tangent is 0. Slope of the tangent is 0 means the tangent is parallel to x-axis, because x-axis also has slope 0. So f dash c is equal to 0 means at C the slope of the tangent which is drawn at C is, here x is equal to C, is 0, and if slope is 0 means the tangent and the x-axis both are parallel. So what is the geometrical interpretation? Let me repeat. For a function which is continuous in the closed interval AB and derivable in the open interval AB, and if the ordinates at A and B are equal, then we will surely get one tangent drawn on the curve in between the points A and B, where the tangent is parallel to the x-axis. This is the geometrical meaning of Rolle's theorem. I hope you have understood. Let us see few problems based on Rolle's theorem and how Rolle's theorem is applied to verify whether a function satisfies Rolle's theorem. Let us see. So let us see this example. We are asked to verify whether Rolle's theorem is satisfied for this particular function defined in the interval -4 to 2. So first condition is whether fx is continuous. Now fx is a polynomial. And every polynomial is continuous in the given interval or any interval. So since fx is a polynomial, implies fx is continuous in the closed interval -4 to 2. Number 2. F dash x. F dash x is what? 2x plus 2. Derivative of x square is 2x. Derivative of 2x is 2. Now, obviously the function f dash x or the derivative of fx will not be infinite or will not be something undefined in the given interval -4 to 2. Any point we put, any number we put in between -4 to 2, it will always give something finite. So this implies that f dash x exists in the open interval -4 to 2. Is it okay? Next, number 3, f of -4, that is -4 square plus 2 into -4 minus 8, that is 16 minus 8 minus 8, that is 0, and f of 2, that is 2 square plus 2 into 2 minus 8, that is 4 plus 4 minus 8, that is also 0. This shows f of -4 equal to f of 2. Hence the third condition is also satisfied, that is f of a equal to f of b. Thus, what we can conclude, that f dash 6, therefore there exists C belonging to open interval -4 to 2 such that f of f dash C equal to 0, or f dash C is what? 2x, here f dash x we have found, so 2c plus 2 equal to 0, or C is -1. Hence, we have got a point -1 which belongs to the open interval -4 to 2. So, Rolle's theorem is satisfied for this particular function x square plus 2x minus 8 in the interval -4 to 2. Hence, Rolle's theorem is verified also, we can write. Let us see the next example. Our next example is fx is equal to sine 2x 0 to pi by 2. Now, first condition, fx is continuous in the closed interval 0 to pi by 2. Why? Because fx is a trigonometric function. All trigonometric functions are continuous in 0 to pi by 2. And we also know that the sine function curve is somewhat like this. So it has a continuous part in between 0 to pi by 2. So fx being a trigonometric function, it is continuous. Number 2, f dash x is 2 cos 2x, 2 cos 2x, and 2 cos 2x is obviously derivable in the open interval 0 to pi by 2. What do you mean by derivable? Derivable means the derivative does not become infinite or means it cannot be calculated something like that, or something indeterminate in the interval 0 to pi by 2 for all the values in between 0 to pi by 2. Hence f dash x is derivable. Third one, f of 0, f of a equal to f of b. F of 0 is what? Sine 0, that is 0, and f of pi by 2, that is what? Sine pi, that is also 0. So f of 0 equal to f of pi by 2 implies f0 equal to f pi by 2. This shows what? That the function fx equal to sine 2x satisfies all the conditions of Rolle's theorem. And if it satisfies all the conditions, there exists C belonging to open interval 0 to pi by 2 such that f dash C is 0, or 2 cos 2x is 0. Cos 2x is 0 means cos 2x is 0, or 2x equal to pi by 2, or x is equal to pi by 4. Pi by 4 obviously belongs in the open interval 0 to pi by 2. Hence, the conditions of Rolle's theorem, first of all, it was satisfied, and we have also calculated the value of x, which lies in the open interval 0 to pi by 2. I hope you have understood the problem. Now we will see what is the statement of Lagrange's mean value theorem, LMVT. Now we have understood Rolle's theorem. Now let us concentrate on what is Lagrange's mean value theorem. The statement is, if a function fx is continuous in the closed interval ab and derivable in the open interval ab, we have only two conditions here. In Rolle's theorem we had three, the third one is missing here. Then we can conclude that there will obviously exist at least one real number c, there may be more, at least one real number c in the open interval ab, means the c will not coincide with the terminal points, such that f dash c will be equal to f of b minus f of b by b minus a. F of b means the ordinate at b minus the ordinate at a divided by b minus a. This is the statement. Now what is the geometrical interpretation? Suppose the condition is continuous. Now if it is continuous, then the curve will have a continuous curve in the closed interval AB, derivable in the open interval AB. Derivable means I had already discussed that the tangent will exist at every point within the interval A and B. Then suppose this is x is equal to b, this is x is equal to a. Then what we can conclude? We will get a point C in the interval AB such that f dash c, that means the tangent at C, is equal to f of b, this is f of a, this is f of b. If I join this, then the slope of this line is slope you know, y2 minus y1 by x2 minus x1. Here y2 is f of b, y1 is f of a, and x2 is b, x1 is a. That means the line joining these 2 points, that is p, q, will have the slope equal to the slope at the point C. That means, let me draw it properly. Suppose this is line joining P and Q. Then we will get a point here, which is at which if I draw the tangent, it will be parallel to PQ. So this is the geometrical interpretation of Lagrange's mean value theorem. Let me repeat. If the function satisfies all the conditions of Lagrange's mean value theorem, then we will get a point C in between the interval AB, where if I draw the tangent, that will be parallel to the line joining the endpoints at B and A. These two lines will be parallel. This is the geometrical mean. The problems of Lagrange's mean value theorem could be equally solved as the Rolle's theorem. I hope you have understood what I have explained, and we shall meet again. When I prepare the next video, surely you will get the notifications. Please comment and don't forget to give the like and share with your friends. If any types of problems you have, write in the comment box. See you again. Bye bye. Stay well.